This video has been designed to assist with the assembly of the Legacy Model 1000 and 1500 series. Your Legacy has been kitted and packaged for easy assembly. If you open the bag labeled Master Hardware Package, you will find a number of individually packaged and labeled hardware kits. There are two yellow-handled ball end wrenches that come with your unit. These are to be used to assemble the machine as well as to make adjustments for various milling operations. Many of the components on your Legacy are secured in place using various size locking plates. These must be installed with a projected portion of the captive hardware facing inside the rail. With the locking plates from hardware kit number 2 positioned inside the wide channel of the extruded rails, secure the rail legs and the rails together with the flat head and cap screws provided. It will be important to see that the outside edge of the rail leg is flush with the end of the extruded aluminum rail. You may find it helpful to use one of the rail legs as a spacer for the center support. You'll also want to take note that the rail legs and the center support have countersunk holes on one end. The countersunk holes should all be positioned on the same side of the extruded aluminum rail. Once you've completed the rail leg assemblies, set them aside while you complete the bed assembly. The bed assembly requires the use of hardware kit number 4, the two long extruded rails, the headstock and the tailstock assemblies. Begin by putting two locking plates into the wide channel of the extruded aluminum rail. Position the headstock between the two rails upside down with the threaded shaft facing inward as pictured here. Tightly secure the headstock to the rails with the 1/4 by 1 inch cap screws and washers. Notice that the end of the headstock is flush with the end of the extruded rail. Position the tailstock about 10 inches from the opposite end of the headstock. The tailstock shaft should face inward so that it faces the headstock shaft. In order to ensure that the tailstock slides freely between the two extruded rails, it may become necessary to file the burrs and paint off of the 4 tabs of the tailstock. Locate the tailstock end plate and hardware kit number 6. Use the 8 sheet metal screws to secure the tailstock end plate to the end of the extruded aluminum rails. Notice that the end plate is wider on the top than the rail. Hardware kit number 6 contains 6 mounting blocks marked A, B, and C. Slide 3 of the long narrow locking plates into the narrow slots on the top of each rail. The ABC blocks will secure to the narrow locking plates using the 1032 by 1 1/4 inch cap screws and star washers. Notice that the A block coincides with the headstock. The B and C blocks should glide freely. With the flathead screws positioned down, we're now ready to secure the bed assembly to the rail legs. Use the 1/4 by 1/2 inch cap screws and flat washers that were in hardware kit number 3 to fasten the rail leg assemblies to the A elevation blocks. The cap screw goes through the long slots in the middle of each leg and into the tapped holes in the center of each elevation locking block. With the rail leg attached to the locking block, you'll want to make the final adjustment for the bed assembly and the rail legs. At the headstock end, the bed rails must be flush with the recessed edge of the leg, as pictured here. Now you can tightly secure the cap screws on the elevation blocks. With the bed assembly properly aligned, you're ready to secure the B and the C blocks into place. Locate the headstock end plate and hardware package number 20. With the machine still positioned upside down, attach the headstock end plate to the rail legs with the 1032 by 1/2 inch button head cap screws. If you purchase the motor drive system, mount the gear cover in lieu of this end plate. Next, we'll mount the tailstock end panel with hardware kit number 8. Mount the tailstock end panel using the 1" by 4" spacers as pictured here. The large round hole in the end panel is used when the motor assembly is attached. It must be located as you see it pictured here. Hardware kit number 5 contains the X-axis support assemblies. First, we'll attach the support blocks to the metal plate. Next, we'll slide the 2 narrow locking plates into the extruded aluminum rail. Mount the assembly with the 2 support blocks on the headstock end as pictured here. At this point in time, it is not necessary to firmly tighten the cap screws. Mount the single support block so that it moves freely. It is now time to turn the unit right side up. You're now ready to mount the pre-assembled router carriage. The router carriage slides onto the top rails at the headstock end of the machine. The glide blocks have been mounted loosely to the carrier tray. With the glide blocks loose, the carrier tray will have some play in it. Use the small ball end wrench to lock the 4 glides snugly against the rail. Use the same wrench to lock the 4 glides on the top. Hardware kit number 12 contains the X-axis split nut and will mount to the front of the carrier tray. To identify the front of the carrier tray, the headstock should be on your right and the tailstock on the left. First, attach the mounting base with the 2 1032 by 3/4 inch cap screws. Then mount the locking knob plate to the split nut mounting base using the 1032 by 1/2 inch button head screws. You can then attach the split nut to the locking knob plate. Notice the position of the washer. Hardware kit 7 contains 4 small locking plates. These locking plates and screws can be used to mount the rotary table or a flat milling table to the rails of the machine. Kit 9 contains the hardware for the X-axis drive system. Insert the long drive shaft into the support assembly located at the headstock end. The squared end of the shaft should be pointing off the front of the headstock. Mount one of the double locking collars onto the back end of the shaft. Use the packet of grease provided to lubricate the shaft where it will fit into the support blocks. Insert the support shaft into the single support assembly located at the tailstock end and mount 1/2 of the second double locking collar to the shaft. Then lubricate the shaft where it fits into the support block. Slide the 2 single locking collars onto the long or X-axis screw. Secure the screw to the drive shaft at the headstock end. Support the screw in the middle with the split nut mounted to the carrier tray. And then lock the lead screw to the shaft at the tailstock end. Leave the support assembly to move freely. We'll make a final adjustment later. Snap the split nut onto the lead screw. Your router should have a plastic base held on by 3 or 4 screws. Remove the plastic base from your router. Orient the router on top of the aluminum base plate. We position our router so that the plunge release mechanism is located on the operator side of the machine. Once the router is centered over the opening of the base plate, use the hole pattern to identify at least one of the holes. Place the plastic base from your router on top of the aluminum plate and mark the holes. Once the holes have been drilled, you'll want to countersink the underside to receive the mounting screws. With the router base mounted to the router tray assembly, slide the glides into the inside channels of the router carrier. Notice that the Y-axis split nut mounting base is located on the headstock side or the right side of the router carrier. Tighten the 4 top guide locking screws. Place pressure against the glide bracket on the right side and tighten the cap screws on both sides. The Y-axis screw will be mounted using hardware kit number 13. Slide the locking plates into the right side rail of the carrier tray. Use the 1032 by 1 inch cap screws and flat washers to fasten the two Y-axis screw support blocks to the front locking plates. The flat surface of the blocks must face in. Now slide the two shaft collars onto the Y-axis screw, and then place the two washers on the milled ends of the shaft. You're now ready to slide the ends of the screw into the two support blocks, making sure that the longest milled end with the flat surface is positioned through the block on the operator or lead screw side of the machine. Let the Y-axis screw determine the position of the carrier tray support block and lock it into place. Use hardware kit number 15 and secure the split nut locking knob plate to the mounting block and lock the split nut onto the lead screw. Notice the position of the washer between the knob and the plate. Mount the extension shaft in hardware kit number 14 onto the end of the screw and then secure the hand wheel to the extension shaft. Slide the two long narrow locking plates in hardware kit 17 into the underside channel of the outside rail and mount the two template support brackets to the locking plates. Secure the template follower to the router base using the 1032 by 1/2 inch cap screws and flat washers. Notice that the support brackets are adjustable and can be locked into place along the length of the rails. The stylus attaches to the template follower anytime contoured milling is performed. You're now ready to mount the router to the carrier tray. The pivot arm assembly has two telescoping arms with a bearing on each end. Apply grease on the inside of each of these bearings. Detach the telescoping arm with the largest bushing and mount it onto the end of the spindle shaft. The arm with the small bushing mounts to the end of the drive shaft. Use the cap screw to reattach the linkage. Slide the standard indexing gear onto the end of the spindle shaft and lock it into place with the locking knob. Locate the duplex gear and slide the gear onto the round shaft. Notice that the smallest gear faces in toward the headstock. There are 7 drive gears. Locate the second to the largest gear, or the B gear according to the gear chart located on the headstock of the machine, and mount it to the drive shaft. It may be necessary to gently file the end of the drive shaft. Your machine will have 2 drive handles, one with a square hole for the drive shaft and one with a rectangle hole for the spindle shaft. Assemble the drive shaft handle as you see here. Mount the thin brass spacer to the drive shaft and then lock the handle on with the cap screw and washer provided. Engage the gears by sliding the telescoping arm and lock the cap screws into place. Locate the dead center, the index drive center, and the 4 index hubs. The index drive center is a number 2 Morris taper and mounts into the spindle shaft. Wedge the taper into the drive center by firmly tapping it into place. You may remove the drive center by placing one of the ball end wrenches through the spindle shaft and knocking it loose. This facilitates the use of a 4-jaw chuck or other lathing device. Now place the dead center into the tailstock shaft. Insert a pointed router bit into the router and then align the tip of the bit with the tip of the dead center. With the router aligned over the dead center, we can accurately position the measuring scale for the Y-axis. The 0 mark on the scale should then align with the pointer on the carrier tray. To align the scale for the x-axis, mount a hub to the end of a workpiece and chuck it into the machine. Use a straight edge or a square to locate the end of the workpiece as it relates to the outside rail. Mark the rail to identify the 0-inch mark for the x-axis scale. Set the bottom of the scale along the outside edge of the outside rail. You're now ready to make a couple of final adjustments to the machine. Loosen the support blocks and the support block mounting plates on each end. Slide the carrier tray to the headstock end and retighten the mounting plate and the mounting blocks. This adjustment will ensure that the relationship between the carrier tray and the lead screw is accurate. Repeat this procedure on the tailstock end. You will find that the movement of the carrier tray may be somewhat stiff. Now is the time to use the Dynaglide spray lubricant to lubricate the rails and screw on the machine. That completes the assembly of the Legacy Model 1000. We'll now assemble the accessories that constitute the Legacy Model 1500. If you purchase the floor stand assembly, lay out the floor stand as pictured here. Notice the position of the narrow and the wide channels on the extruded rail. There are a total of 8 triangular mounting plates, 4 for each leg. Lock each mounting plate into position using a single long narrow locking plate and 2 single hold locking plates. Position the brace with the pre-assembled elevation system so that it measures 3 3/4 inches from the end of the floor stand rail. Use 2 wide locking plates and mount the long triangular mounting plates to the outside of the legs adjacent to the elevation assembly. If you purchase the motor drive system, you'll want to insert the 4 wide locking plates for the limit switches into the bottom rail before you mount the floor stand to the machine. This view shows the floor stand being added to a previously assembled Model 1000. If you purchase the Model 1500, you'll want to mount the floor stand assemblies to the rails before turning it right side up. Attach the adjusting hand wheel to the elevation screw. Attach the elevation pivot brackets to both the A and the C elevation mounting blocks using 1032 by 1/2 inch button head screws. Note that the nylon washer goes next to the bracket. Lower the elevation stabilizing bars until they become engaged in the elevation pivot brackets. Secure them into place using the bolts and the nuts provided. If you purchase the motor drive assembly, and you haven't done so already, replace the U-mounting bracket with the gear cover. Mount the 2 electronic limit switches to the locking plates that were placed into the side of the bottom rail. Note that these switches are adjustable along the length of the machine. The control box hangs freely on the bottom rail. The junction box mounts to the bottom rail with 2 small locking plates. The limit switch activator plate mounts to the front of the carrier tray. The 60 and 80 inch units have a lead screw that extends down to the motor drive at the proper distance. If you are mounting the motor drive system to the 40 inch unit, you will need to add a 7.5 inch extension shaft to the lead screw. Slide one of the Lovejoy couplers onto the end of the lead screw. Slide the second Lovejoy coupler onto the motor and mount the motor to the end plate. Insert the spider shock absorbers between the Lovejoy couplers, then slide the two couplers together and lock them into place. You can adjust the end plate from side to side if you find that the motor shaft is not properly aligned with the lead screw. Connect the motor wire receptacle to the motor wire plug that comes from the junction box. With the drive handle removed, you can now place the gear cover over the end plate. The dust bag is mounted with 8 snaps that screw into the bottom of the adjustable rail. The dust hardware package consists of 3 separate items which mount to the carrier tray. The 2 vinyl shields mount to the side rails with Velcro. The dust port mounts over the opening on the template follower. And the hinged plexiglass shield mounts to the front of the carrier tray. If you purchase the gear-driven rotary table, which is an accessory to any of the legacy ornamental mills, mount it to the inside or adjustable bed rails using the 4 locking plates previously installed. This completes the assembly portion of the legacy ornamental mill.
Thank you for purchasing a legacy ornamental mill. You will soon discover that your mill is limited only by your imagination. Scary thought, isn't it? In this video, we will teach you the basic theory and operation of your ornamental mill so that you can get started right away. Now, let's stop wasting time being pleasant and get down to business. To begin with, you will want to use a dry lubricant to lubricate the rails on your machine. We highly recommend a product called Dynaglide. If you don't have some type of dry lubricant, give us a call and we'll get you set up. This product you simply spray it onto the rails and then let it dry. Apply it to both the X and the Y axis rails and let it dry. Once it's dry, the carrier should move easily but still be fairly tight. To get started, you'll need 3 turning blanks, 12 inches long, 1.5 inches square. You'll notice that I've also cut the corners off on a table saw. At this end, we've drilled a pilot hole for the center on the tailstock. At this end, with 2 screws, we've mounted the index hub. These blanks are now ready to put into the machine. Next, we'll need to adjust the tailstock for the proper position to insert the stock. Use the Allen wrench and loosen the 2 locking screws inside the tailstock so that it will slide into position. Now you can take the blank, insert it into the machine, and just slide that up until it's supporting the stock between centers. This handle now can be open or closed. You want it set at no more than a 30-degree angle here in order to lock that in place. If you open it up farther than that, you'll overload the headstock as you close the clamp to secure it in place. Now this stock is fixed, ready to mill. The first thing that we're going to do is to mill this stock round. So we'll set up the headstock here. We'll actually take the gears off and we'll show you a technique with no gears at all in milling it round. For this technique, we'll completely remove the gears here. So you just take off the black knob and the index gear will come right off the spindle shaft. Now I'll also take off the duplex gear just to get it out of the way. And we'll put on the spindle shaft handle directly onto the spindle shaft. Now we can rotate the stock directly. Now we want to adjust the bed level at each end. To do that, we simply loosen the cap screws on both the front and the back sides of the machine and then raise or lower the bed. If you have the floor stand, this is simple. You can simply turn the handle. Otherwise, you'll be sliding it by hand. For this diameter stock, we want to set it to the 5th hole, starting at the top here hole number 1, 2, 3, 4, 5. When this hole opens up, we'll be at the right location. Now simply lock the screws on both the front and the back side. For milling the stock round, we'll use Magnate's bit number 2704. It's a bottom cleaning or surface planing bit. Now we will position the router bit for the cut. The router can move in the y-axis back and forth. At 0 it will be centered. However, for rounding the stock, we do not want the bit centered. We'll lock it onto the lead screw here and bring it to 0, and then we will back it off 2 turns to the back side or ½ inch. We can also set a stop here so that anytime we bring it into that stop, we know we are offset ½ inch from center. We will also leave the split nut on the x-axis open so that we can manually slide the carrier tray along. We will set a stop, however, at 2 inches from the end on the x-axis. So simply slide the carrier tray into place and then lock the shaft collar. To set the plunge depth, we'll simply turn the stock till there is a flat surface up, and then we will plunge the router down till the bit is resting onto the stock. Now the milling procedure will be as follows. We have our plunge depth set, we have our y-axis and our x-axis set. So we'll simply plunge down, turn the router on and bring it over center, but it's offset ½ inch. And then as we rotate the handle counterclockwise, we will slide the carrier tray along manually. First we'll need power to the router. Alright, now we have our router plugged in, we're really ready to go. Now we start by making a test cut just to see if we've left any of the surface as we rotate this. Here we have just a little bit left on this side, so we'll readjust our plunge depth for just a few thousandths, maybe 10, 20 thousandths of an inch, and cut it again. Okay, we're removing all of the surface now, completely around, so we're ready to continue the cut. Okay, there's one step, is by simply rotating it and moving it by hand. The other way that you can do it is to actually rotate both these handles at the same time. I'll show you that. It's a little tricky. Now as you rotate these two handles, this handle will rotate the stock. This one will feed the router along with the lead screw. So this time we will lock it onto the x-axis lead screw as we're making our cut. Now you can see we have milled around. Both techniques will mill it extremely smooth. However, the first one will give you a slightly better finish. Next we're going to mill this part on a taper. To do so, we'll need to adjust the bed. You'll need to loosen the cap screws on both the front side and the back side. Do this at the tailstock end. And then simply raise this. On this particular part, we'll raise it all the way to the top and lock it down, both front and back. Now we're going to slide the carrier tray along the x-axis to 4 inches. And here we'll set a stop so that we won't cut all the way up to the beginning position. If you remember, we started at 2 inches. The tapered section now is going to start at 4 inches from the end. Now with the bed set at a taper, this end raised up, and the stop and the x-axis set at 4 inches instead of 2 inches, we're ready to cut our taper section. The only thing that we'll need to do now is to reset our plunge depth. We'll simply plunge the bit down until it rests on the stock at 4 inches, and that's the depth that we'll use. Now you can see that the stock has a straight section for the first couple of inches to 4 inches from the end, and from there it tapers down to the very end. Next we'll set up and we'll cut some flutes in here, and then we'll come back and cut some joinery at the end to show you the indexing system. For milling the flutes, we'll use the indexing that's built right into the indexing gear. So we'll replace the handle with that gear. Now this gear has 24 positions on it, so anything divisible by 24 can be milled on here. We'll cut 8 flutes on this section, which means we'll go every third hole. The indexing head is pretty straightforward. The pin can be held back with this locking plate. To release it, just press on the plate and the pin will slide forward. It's spring-loaded and it'll lock into any one of those holes on your index gear. To begin with, it doesn't matter where we start, but we'll go every third hole once we start cutting flutes. For the fluting, we will use Magnate's bit number 805. If you haven't seen this chuck before, it's because it's built specifically for the Porter cable routers. It's called the Eliminator chuck. It makes changing your router bits very fast and easy. If you have a Porter cable and want one of these chucks, just contact us and we'll set you up. The next thing we'll want to do is to set the y-axis stop so that instead of being a ½ inch off center, we'll be right at 0 or centered on the turning blank. Lock that cap screw there. I'm also going to set the x-axis stop so that instead of being at 4 inches, it's going to be at 4.5, and that will be our starting position. And at 11.5 inches, we will set the other stop, so our flutes will be that long. These are going to be blind stop flutes. Next, we'll simply set the plunge depth by dropping the bit down until it just sets on the stock. Once it touches the wood, we can set the plunge bar for any height we want. I'm going to plunge down approximately 1/8 of an inch and lock that in place. Now with our indexing set, our router centered, and our stop set, we're ready to start cutting flutes. Now you can see that the flutes are evenly spaced, and we have 8 of them because we used every third hole on a 24 position indexing plate. Also notice that the bed is the same level, so the flutes are the same depth, the full length of the stock. If you adjust one end higher or lower, the flutes will be teardropped. With the flutes cut, we're going to set the bed back to level by setting this end back to the 5th hole on both sides. And then we'll come back and set our stops. We will mill a flat in this first couple inches at 90 degrees, and then we'll cut mortises in here for our rails to come into. All right, loosen the cap screw on both the front and the back side, and again adjust the machine until it's back to the 5th hole, 1, 2, 3, 4, 5, and lock it in place again. Now to mill the flats in this section, we'll need to set the x-axis stop along the lead screw here. We'll set it at 2 and at 3 inches, and that'll cut a flat surface here. We'll need to do a couple of things. First, we'll move the lead screw so that the router can move all the way back and forth across the stock. Then we'll set the first stop at 2 inches. Then move the carrier down 1 inch to 3 inches and set the second stop at this position. Now I've changed the router bit back to the 2704, the surface planing bit, so that we can mill a flat surface. We'll just plunge it down till it rests on the stock like before, and then adjust our plunge depth here for approximately 1/8 of an inch. Now this technique is kind of like mowing the lawn. We'll just make passes back and forth, each one being about 1/4 inch wide. Now we'll index the 6 holes, which will be 90 degrees, and then repeat the same operation. For milling the mortises, we'll use a 1/4 inch spiral upcut. You could use a 3/8 or 1/2 inch or whatever size you want for the mortise. In this case, we'll use the 1/4 inch, which required a collet adapter for the eliminator chuck. Now to mill the mortise, we'll want to center the router in the y-axis, so we'll put the router at 0. We can set the stop at that position. We'll leave our 2 stops on our x-axis at 2 and at 3 inches, or we can move those for any length that we want. Now we'll plunge the bit till it just simply sits on top of the stock, and then adjust our plunge bar for the depth of the cut. We'll cut this about 3/8 of an inch deep. This will need to be made in multiple passes, about 1/8 of an inch at a time. You'll also notice that when we plunge, we start at one end and cut only in one direction. Then we'll lift the router out, come back, plunge deeper, and repeat that process. Now we'll index at 6 holes, just as we did the flats, and put that into position, and we're ready to cut the next mortise. Okay, here you can see the finished part. We have a straight section with flats at 90 degrees for the rails and the mortises, and then the tapered section with the evenly spaced flutes. Well, all right, so far so good. We've learned how to mill the stock round, how to set the bed for tapering or straight cuts. We've also learned about the indexing system. Now we're going to cover the spiral drive and the gearing. We'll start here by defining one simple term, is what we call pitch. When you hear pitch, you'll think about how far the router is traveling along the length of the stock for every rotation of the stock. So we'll define it as such. The distance divided by each rotation. Now as we look at some parts and start using the system here in a second, you'll soon find out what that means. But just keep in mind, pitch equals the distance the router travels for every rotation of the stock. Now there's a simple formula that we use once we have defined pitch to decide how to set the pitch on the machine. we'll let P equal pitch. So to calculate the pitch, we'll use the diameter of the router bit, whatever the router bit diameter is, times the number of starts. Again, this will mean more as we get into this and you'll see it operate on the machine. But let's just use this formula right here and plug in a couple of numbers, and then we'll show you how to set that up on the machine. Let's say, for example, that we're using a router bit that is 2 inches in diameter. And let's say that we're going to do 3 starts. So in this case, 2 times 3 would give us a pitch of 6 inches. We would simply set the gearing for a 6-inch pitch. Let's plug another number in here. Let's say that we have an 1.5 inch cutter, and we're going to do 2 starts. Then our pitch would equal 3 inches, and so on. Now, if you know any of the 3 variables, the pitch, the diameter, or the number of starts, you can calculate the other 2. So we can manipulate this formula. For example, I'll just show you this real quickly. Let's say we want to know what diameter of the bit we should use. But we know what the pitch is, and we know how many starts we're going to use. So we simply take the pitch divided by the number of starts, and that'll tell us the diameter of the bit. Or if we know the pitch and we know the diameter of the router bit, we can calculate how many starts by using this formula here. All right, now let's take a careful look at the gearing system here and decide how we're going to use this. Let me explain this real quickly. There are 3 parts to the gear system. The first is these 2 large gears working together. We call this the gear reduction. The last gear here at the end is the drive gear, and that will determine your pitch. The center gear here will determine the direction of the spiral. You can think of this as a 21-speed bike, and that'll help. If this represents the front sprocket of your bike and this gear represents the rear sprocket, if you change the rear sprocket, you'll change the gear. On here, you'll change the pitch. And there are 7 of these gears. So if I simply change the last gear here, we will get one of 7 different pitches. Now, this one here, if I change this mechanism, it will change the direction. In 21-speed bike, that doesn't matter, so we're a little bit different here. But that'll make it either a right-hand or a left-hand spiral. This will change one of the 7 pitches. Now, if we change the gear reduction set, we go with the 0.25 times gear reduction or the 2 times gear multiplier, then we'll get a whole different range of 7 pitches. So each gear reduction set will give you a set of 7 pitches, giving you a total of 21. Now, the Model 1000 comes standard. With this set right here, we call it the standard gear reduction set, so it has 7 different pitches. The Model 1500 includes the 0.25 and the 2 times, so you have up to 21 pitches. If you have the Model 1000, you can buy these other gears as upgrades if you wish to get the other pitches. Now let's take a look at the gear chart and see how to set these gears to get a pitch. On your headstock, you will find the label for the gear chart. This will tell you which gears to use for which pitch. It's a little difficult to read here, so we'll look in the manual at the chart, but you can see that this range of numbers right here represents the pitch, and then the chart will show you how to set the gearing for each one of these pitches. Now here's the chart as you'll find it in your manual. It's the same as the headstock chart. This is just a little easier to read on film, so we'll use it here. Now on your chart you'll see these rings, and they represent the diameter of each one of the drive gears. If I take any one of the drive gears and lay it on this chart, make it even at the bottom here, I can identify the drive gear. This, for example, is the C gear because it lays right on there. That's the diameter. Now, once you've identified the drive gear, this chart will tell you what pitch that'll set. If we use the C drive gear, as you find in this column here, as you look across that row, you'll see what pitches it'll set depending upon which gear reduction. Now, with the standard gear reduction set, as comes with the Model 1000, you'll have this column here, and that's why it's dark, because that's the standard set. With the C gear and the standard set, you get a 4-inch pitch, meaning the router is going to travel 4 inches along the length of the stock for every rotation of the stock. Now, if you change one of those drive gears, let's say you put the A gear on, you'll get a 2-inch pitch. If we put the F gear on, we would get a 6-inch pitch, and so on. We'll be within that range. Now, if we change the gear reduction set, the C gear, instead of giving us a 4-inch pitch, you'll see it gives us a 1-inch pitch. The reason that's called the 0.25 times is because that's exactly what it does. It's 1/4 of the original value of these pitches. So 0.25 times 4 equals 1 inch. Now if you go the other way, you look at the 2 times gear multiplier, that's exactly what it does. If you take 2 times 4, you'll get a pitch of 8 inches. So by using the C gear in one of these gear reductions, we'll either get a 1-inch, 4-inch, or 8-inch pitch. For our first example, we determined we wanted a 1-inch pitch using a 1-inch diameter router bit and a single start. To get the 1-inch pitch, you just look in all of the columns till you find the number 1, and then I'll identify that we use the C gear and we'll use the 0.25 gear reduction set. For our second sample, we had still the 1-inch router bit, 2 starts, gives us a 2-inch pitch. So for a 2-inch pitch, we'll use the standard gear reduction set, so we'll need to change the gear reduction, and then we'll change to the A size drive gear. On the third one, we'll use a 3-inch pitch, so we'll leave on the standard gear reduction set. We'll just change the drive gear to the B size gear to give us the 3-inch pitch. We're going to make 3 different parts to illustrate how to use this formula. In these parts, we'll use the same size router bit. The router bit diameter will always be 1 inch. Okay? We will just vary the number of starts to show you how this works. On the very first part, we'll use a 1-inch diameter bit and we'll do a single start. On the second one, we'll do a 2 start, and on the third one, we'll do a 3 start. Just work this formula real quickly. It's very simple to see. On the very first part, the pitch will equal 1 inch. On the second part, it will equal 2 inches, and on the third part, it'll equal 3 inches. Again, you can plug any diameter bit in there, any number starts, and that'll tell you the pitch. Then look at your chart on your headstock, and you're ready to go. Now for milling these rope spirals, we're going to use bit number 7571. It's a 1-inch diameter rope molding bit. You could also use bit number 7551, which is a 1-inch diameter barley twist bit. It doesn't really matter, both will work the same. Alright, we'll start by setting up the machine. This part has already been milled like we did previously. Now we're going to set the machine, we'll set the stops for the x-axis at 2 inches and also at 6 inches. Then we'll set the router so that it's set in the y-axis at 0, so it'll be centered directly over the stock. Next we'll need to set the plunge depth. Now to do this, I'm actually going to move the router off to the side a little bit and plunge down until the shoulder of the bit is resting on top of the stock, and lock the plunge down right there. Here you can see how the shoulder of the bit is resting on the top surface, and that's the depth that we'll need to cut. Now to set the gearing. We're going to use the C-size drive gear and the 0.25 gear reduction set. So the first thing to do is to put on the 0.25 gear reduction set. We'll take off the standard set. These just slide off. And we'll start by putting on the index gear and securing it in place. And then the duplex gear, which has the 2 gears that are bolted together. Now at this point, you'll want to engage these 2 gears to begin with right there. The next step is to change the drive gear. So we'll take the handle off, take off the spacer, and then the drive gear. We'll replace it with the C-size gear for the 1-inch pitch, and then we'll replace the spacer and the handle. And finally we'll engage the gears up to the drive gear. Now these gears can all shift back and forth and float. They're built that way so that you can mill tapers as well on spirals. So once you get it engaged, you'll then want to just turn the handle and make sure all the gears are fully engaged and rotating. If they slip at this point, you simply re-engage them in both directions, and then they'll lock in fully and be ready to start cutting. All right, we're ready to cut our spiral. We're going to start by cutting just around the circumference with a half bead to begin with. So we'll leave the split nut open. The threads will not be engaged into the drive screw. The plunge depth is set. We'll just bring it over center and rotate the stock one full rotation. Now here you can see we've milled completely around the stock using the rope molding bit to cut that half bead. Now from this position we'll start our spirals. This time as we're making our cut, we're going to close the split nut down onto the lead screw. Make sure it's fully engaged and brought back to the starting point. Now when we bring it over center and turn the handle, it'll cut down to the 6-inch mark. Now at this point, we want to cut a bead around the end. We'll simply open the split nut and cut around this end. Now here you can see the bead, or the half bead we cut at the start and at the end, and the single start spiral. If you look at this and you measured the distance between those cuts, it's exactly 1 inch, and that was controlled by the gearing. No matter how fast or slow you turn the handle, it'll feed it exactly 1 inch because of the gear set. This is called a single start spiral. All right, next we're going to set the stop, so instead of ending at 6 inches, we'll move it down 1 inch and cut at 7 inches. That'll cut a bead here in the center. And then we'll do a 2-start spiral at this end. So we'll simply move the scale down to 7 inches, set our stop at that point, and then move this one down to, let's go to 11, and lock that stop in place. Next we'll need to change the gearing for the 2-inch pitch. We decided we needed the A drive gear, which is the largest of the drive gears, and we'll need the standard gear reduction set. So we'll begin by replacing the gear reduction. Once the gear reduction is in place, go ahead and engage those gears, lock them in place. Now we'll change the drive gear. Now with that in place, we'll engage these gears, bring them into place, and then again just test it to make sure they're fully engaged and ready to go. The plunge depth, the y-axis, is all exactly the same. We have moved our z-axis to start at 7 and end at 11. So now we can just cut a ring around the beginning and start the spiral. Next, we'll close the split nut onto the lead screw, bring it up to the starting position, and make our spiral cut. Here you can see the spiral that we've just cut. Now the cutter is 1 inch in diameter, as you can see here. The pitch is 2 inches, so it left a 1 inch spacing in between. So all we need to do now is to bring the router bit right in between these two cuts and mill the second start, and it'll finish off a 2-start rope. The first start of the spiral ended at 11 inches. We can see that on the scale here on the carrier tray. So what we need to do is lift the router bit out of the cut, simply open the split nut, and then slide it 1 inch, or the diameter of the router bit, and lock that back onto the lead screw. That will set it so that it's in between the last two cuts. Once again, if we ended at exactly 11 inches on that last cut, on the very first pass, we'll then simply open our split nut, raise the bit out of the stock, and slide it back 1 inch, or exactly the diameter of the bit. And we lock it back onto the lead screw, and then crank it back to the starting position. We always want to cut one direction, from the headstock towards the tailstock, or the opposite, it doesn't matter which, but it should always be the same direction. You can see the 2-start spiral. The second pass we just cut here, and the first pass we cut here. The space in between each cut is 1 inch. The pitch set by the gearing was 2 inches. For the last part, we're going to do a 3-inch pitch. So here all we need to do is change the drive gear. This is for the 2-inch pitch. The B size gear will give us a 3-inch pitch with the standard gear reduction set. And finally engage the gears and test that they're fully engaged as they run. For the 3-start spiral, I want to show one other thing here. You'll notice that this blank has not been rounded. We have cut the corners off on a table saw to remove most of the stock, but you can cut the spirals directly into the blank without rounding it first. The gearing is set for the 3-inch pitch. The plunge depth is exactly the same. The y-axis is already set, so all we need to do is set our x-axis where we want to begin and end this cut. We'll start at 2 inches and we'll finish, I'll say, at 6 inches. Now one thing that I like to do is to engage the split nut and turn it till it's on an even number. And at that point, that's where I'll set my stops, make sure the handle is straight down. Every turn of this handle is 1/4 of an inch. So if I do it that way, then my stops will be when they end straight down. I'll know exactly when I'm at a single digit, like 1 inch, 2 inches, 3 inches, and 4 inches, and so on. So we'll put the handle straight down and adjust our stops to match exactly. Now we'll begin the cut by opening the split nut and cutting around the circumference. The first thing you notice is that this makes more sawdust. Kicks off because we didn't round it first. So it doesn't matter if you choose to round it or not. But this will put more wear and tear on this particular router bit. You can see we've cut all the way around. If one of these surfaces was not deep enough, we would adjust our plunge depth accordingly. But this one looks good. It's ready to go. Now at this point we do the exact same thing. Simply open the split nut, slide it back 1 inch, and lock it onto the lead screw. And it's positioned ready to cut our next pass as soon as we wind it back up to the beginning position. The second pass will do the exact same thing. But let me show you one little thing right here that you'll want to note. Let's say that you're milling a real long piece and you get way down here at the end. Now if you open the split nut, move it back 1 inch and close it, you can see I've got to now crank it back here 30 inches. That's a lot of cranking. You can avoid that as well by using the split nut. And it doesn't matter where the stock is, as long as the bit is centered. You open the split nut, you can now just slide it back down to the beginning position. Now once you've done that, you've lost your synchronization, so you must synchronize the bit with this cut that you've just made. If you slide that bit along, at some point the bit will plunge right into the same groove. Once it does, if you lock the split nut, you're again milling in that exact same spiral that you were just in. From that point, you can then open it and move it 1 inch and lock it in place. Now I only have to back it up the last couple of inches instead of cranking it all the way from down here at the end. If you do that, remember to synchronize first, then offset the diameter of the bit, in this case 1 inch, and then crank back to the beginning position. And then your spirals will come out just right. Now let's take a close-up look and see if I'm right. Okay, as we zoom in here, you can see we have made 2 passes. If we were to trace this cut here all the way around and measure that, it would be 3 inches. That again is set by the gearing or the pitch. We then moved it 1 inch to cut our second pass. So we've cut 2 of the 3, that's a 1 inch spacing. You'll notice there's a 1 inch gap in between. So we'll take the bit, move it back 1 inch again, set it right in that position, and begin the cut to finish our 3-start spiral. So I'll bring the router bit and I'll plunge the bit right into the last groove that I cut, and then we'll make the 1 inch offset, and then we'll crank back to the beginning. There's my last cut. Lift it out of the cut, move it 1 inch, lock it down, and bring it back to the starting point. Now the reason I don't plunge here at the beginning to make my cut, I crank it off to the side to start it, is if you plunge directly on and let it sit there, you can burn the wood or you can create a little divot. So by bringing it from the side over, it eliminates that problem. Now I'm going to open the split nut right here and I'm going to cut around the circumference. The next thing I'm going to do is I'm going to move the router down 1 inch and make a second cut. Now if I leave the split nut engaged, then by simply cranking the handle, it'll move it exactly 1 inch. Notice the handle is straight down. I set it up that way intentionally. I go 1 turn, that's 1/4 of an inch. 2, 3, 4 turns is 1 inch. Now I'll set that stop at that position, open the split nut, and make the second cut. Now let's take a look. Okay, here's the 3-start spiral. The spacing between each cut is 1 inch. The total pitch is 3 inches. And here we've moved the bit down exactly 1 inch to cut this bead. You can move it any distance that you want, but in order to form a full bead with a point cutting roundover or rope molding bit or some other bit like that, you move it the diameter of the bit. Next, we're going to mill some flat stock. So instead of working between centers like we did on the last section, we'll be working on the flat bed. Now when you assembled your machine, there was some hardware locking plates that went inside the bed rails, the inside two rails. What you need to do is cut a board, and I use 3/4 inch MDF because it's nice and stable and flat. Cut it exactly the width of the inside rail so it fits inside the two outside. Then we'll take some hardware and just mount it to the rails here. Now the hardware that comes with the machine are actually flatheads. I'm using cap screws instead. They extend up here and get in the way, but I can use my Allen wrenches to set them. You don't have to go to a screwdriver. It doesn't matter what type of hardware you use, you just need to mount the table. Now once the table's on there, you'll notice that we can move it. I have put a 1/2 inch spiral up-cup router bit in here. What I will do is I will lock carrier onto a position, and I'm going to set it at 30 inches in this case. I'll also set the router at 0 or centered here, and then I'll plunge the bit into this hole. Now I show you how to make this hole to begin with, but once that's in place, that table is in the position I want, I will then lock the table down. Now to make this table, all I did was simply set the table where I wanted it, positioned on the stock, and of course it can be the full length of the machine. I'm just using a short section here to show you a demonstration. But once the table's on and positioned where you want it, then for the rotary table, what you'll do is put the 1/2 inch spiral up cut in, position the router wherever you want it, pick an even number like 30 inches or 25 or whatever you desire, set it at 0, and then just plunge down in and cut that hole. Now this bed is set in place. We're ready to mill on this flat table. All right, now what we need to do is adjust the bed. We'll need to lower this bed to give us clearance for the stock. We'll simply loosen the cap screw on both the front and the back, and then lower the bed down. Now we're going to go to the 6th hole on the one side, or the 11th total hole from the top. If we start here at the top hole, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or we can simply go 1, 2, 3, 4, 5, 6, and that is the hole we want to end up at. When that hole is open and lined up, we'll go ahead and lock these in place. Make sure you set all 4 legs to the exact same position. Now this blank has been cut 12 inches long, 3 inches wide. It's just 4/4 stock. We're going to use this as a sample. We'll plane it, and then we'll cut some parallel flutes in it to show you how to use the XYZ milling table. We'll start by attaching the stock to the table. Easiest way to do this, there are several ways, but the easiest way is just use double-sided tape. This tape can be purchased from several different sources. It's actually like the carpet tape, only it holds a little bit stronger. Now if you put too much tape down, you'll never get the part off the board. So we'll just put a piece at each end, like so. Peel the backing off, and this board is now ready to attach to the table. The question is, exactly where do we put it on the table? You look on the table, you see a line that's been scribed on here, drawn. And the way that I did that line was that I took and put a V-groove bit in the router. Once I had the V-groove bit in there, knowing that this stock was 3 inches wide, if I'm at 0, I want to be at the center of the stock. So I moved the router off 1.5 inches to the near side. Put that V-groove bit in there, plunge down, and just ran it along the table, and that scribed a line in here. And I took a pencil and made it darker so that I could see it. Now we'll take the stock. I've already pulled the backing off the tape, and I'll just align it with that line. Now once I have that in place, if I want to go to the center of that stock, I just go to 0. If I want to go to the edge, I go off 1.5 inches. Now I'm going to show you a technique how to plane stock. We'll simply take the router bit, This is a surface planing bit that I have in here, the 2704 again. I'm going to drop it down till it touches the surface, and then I'm going to raise my plunge bar, just a little bit, 1/16 of an inch or less. And I'm just going to make multiple passes across here, kind of like mowing the lawn. Here's how it works. Now that planes it extremely smooth. You'll notice that for each pass I was turning exactly one turn of the handle. That moves it 1/4 of an inch. If you're cutting a real light pass, you can move it as far as a 1/2 inch. The deeper passes you want to move it less. The advantage of planing your stock this way is a couple of things. Number one, if you have a highly figured wood or a burl or something like that that you would put through your planer, it would tear the grain all out. But by milling it flat, you can do any types of wood. The other advantage is that if I were to put a straight edge on here now, you will see that it has removed any twist or bow or anything. The surface is perfectly flat. That makes it nice when I'm putting together small boxes or pieces that require very precise joinery and precise fitting. I know that my stock is perfectly flat to start with. I have changed the router bit to the 803, which is the 3/4 inch core box bit. Now I'm going to cut blind stop flutes, meaning they're going to stop here at the end. They're not going to bleed off. So we'll need to set a stop on the x-axis. We'll set a stop here at 1 inch from this end, and also, let's say 1 inch from the opposite end. Now those stops are in place. I'll need to set the plunge depth. I'll just plunge the bit down till it sets on the stock, and then set the plunge bar for approximately 1/8 of an inch. Now I'm going to cut these flutes so there'll be 1 inch spacing. If we put it at 0, of course, we're cutting right down the center. So if I move the handle 4 turns, it will move over to the y-axis to the 1 inch off the back side. That's where I'll cut my first flute. We do these flutes the same way. We'll plunge down, slide it to the end, and then bring it out. Always cutting in the same direction. After cutting our first flute, we'll simply turn this handle 4 turns. 1, 2, 3, 4. That'll put it at 0, which again is centered in the stock. Now you can see we've cut our 3 evenly spaced flutes 1 inch apart, and they end 1 inch from the end of the stock. You can control the router in both the X and the Y and the Z axis to create all types of dental moldings and other designs. As you can see, the machine is very simple to operate, easy to understand. Now you can look for more training videos available that'll cover other subjects such as the template follower and flat molding. We'll get into more detail in future videotapes. But this will give you a good starting point and let you start having fun immediately.